A group need not be composed of only named formation. What does it mean? Suppose we are defining group A in terms of a lithostratigraphic column. Now, here formation B and formation C have been defined, and look at the top portion. Here no formation is defined, and this is possible. And again in future, depending on new exposure availability, depending on the road cut sections, highway construction, we might define formation, and then we might be able to define formation D, E, F. The same group exposed at two places can have two different formation names. It happens. Group M has been defined in two places. Now, formation A and formation B are the name of the two different formations for group M, whereas in group M exposure another place, formation P and formation Q have been defined. So, a subsequent geologist might say that formation A is comparable with formation P, or he may say that formation A is comparable with or correlatable or can be correlated with formation Q, and this is common. The groups are defined, can be defined at different places depending on the formation, and later the geologist might compare them by doing actual field work, studying the rocks suitably and then correlating them. And then one of the ways of writing the name, suppose this is the correlation, such a name might come AP formation. This can be possible. If a formation is required to divide into several formations, that means a formation was defined by a geoscientist, and then another geologist comes and with valid reason says that this was incorrect and I need to define several formations within it. That means we are doing revision of lithostratigraphy, and the formal formation is to be raised to the rank to group. What was called earlier as a formation has to be called now as a group. For example, the former formation name was X formation, then as per the revised scheme in lithostratigraphy, X remains as it is, formation is raised to the rank of group. Note that the X term remains same or the geographic term remains the same. Now, let us look into supergroup. What is it? More than one group is clubbed as a supergroup, and it can be bound by unconformities. For example, I have already referred to Vindhyan supergroup as an Indian example. Now, note that this is important, an unconformity may not indicate the same time gap regionally. Suppose at one place lithology A, and then there is an unconformity and lithology B is found in location P, and many kilometers away at location Q I am finding A and the unconformity and B. So, we are tempted to think that the time gap over here, let us say A to B million year, will also be the case in this case A to B million year, but this is even debated. It is not so straightforward, and if this is so, then once we are saying that unconformity can bound supergroup or group, that also becomes sometimes questionable in terms of absolute time. So, lithostratigraphy has its own limitations. Nevertheless, lithostratigraphy should be the starting point in any stratigraphic study of a new terrain. So, in this way we have covered the basic definition of formation, group, supergroup, and below formation member and bed. We have to see some other terms in the context of lithostratigraphy. Take for example the term lithostratigraphic zone or lithozone. This word zone was not there when we defined formation, group, supergroup, and from formation below member and bed, the word zone was not there. What is lithostratigraphic zone, or in short lithozone? It is an informal unit, and where we are defining lithozone, there is insufficient reason or insufficient information to define any formal unit. A zone may include all or part of a bed, member or formation, or even a group. This is important. So, a zone can be a part of a bed, a part of a member, a part of a formation, or even part of a group. Some examples: shelly zone, that means naturally in this zone the rock is shale dominated. Coal bearing zone, that means it has an economically importance and it has coal. Producing zone, it can be oil producing zone, so there can be reservoir. Mineralized zone, the mineralization can be economically important. Metamorphic zone, a zone of metamorphism is observed within a formation or member. Heavy mineral zone, there can be a zone of heavy minerals. We will see heavy mineral stratigraphy separately. Migmatic zone, what is a migmatite? It is a mixed rock. It is neither fully igneous nor fully metamorphic. There is a pre-existing rock where hot igneous melt comes and partially metamorphoses the rock. The light colored part is the leucocratic part of the migmatite, which is dominantly of quartz and feldspar, and there is a melanocratic part which can be dominated by amphibole, biotite, etc. There can be a non-migmatic zone also. Let us give an example of migmatic and non-migmatic zones. I take you to the Himalaya in Himachal Pradesh, India. LKRW is the Larji Kulu Rampur window, MCT is the main central thrust. Satluj river flow direction can be marked. The river is shown by blue color. MCTU is the main central thrust upper. North of the MCT upper, that means this place is the greater Himalayan crystallines, and south of it is the lesser Himalaya, although there is a debate whether this MCTU itself is the boundary between lesser Himalaya or greater Himalayan crystalline, or the main central thrust lower, which is far away from the map, and in this place I tentatively draw here. The debate is whether this marks the actual boundary between the greater Himalayan crystallines at northeast and the lesser Himalaya at the southwest. STDSU is a South Tibetan detachment system upper. The Baspa river has been shown. STDSL is a South Tibetan detachment system lower. J is the location Jeori, W is Wangtu, S is Shongtong, P is Pangi, K for Kasang, A for Akpa. Previous to these authors already worked out the lithologies from this map location. A fieldwork by these authors led the finding that this domain of the Himalayan rocks are dominantly non-migmatic. Therefore, these lithologies were grouped as a non-migmatic zone, and northeast of this line migmatites were found. In this case, the use of the word zone involves several rock types, same with the non-migmatic zone. Here the zone will include several rock types. Like zone, we sometimes use the word horizon, lithostratigraphic horizon, in short, which is called lithohorizon. It is a surface of lithostratigraphic change and it is valuable in correlation. Imagine in this lithostratigraphic succession, across this line some change takes place, then this can be called as a horizon. So, horizon and zone, these two words are different. Now, once we correlate this horizon with another horizon from another lithostratigraphic column, they need not be time parallel or they need not be synchronous. That means, we are dealing with a diachronous correlation. This is absolutely important. Whenever we are doing lithostratigraphic correlation between A, unit A here and unit B, we are putting the dash line and joining them in lithostratigraphy, there is no guarantee that A and B were deposited or were produced or crystallized simultaneously. There are lithological resemblance, therefore, they have been linked, and in such correlation where it is time transgressive, we call it as diachronous correlation. This is very important. It can be required for some practical work, but if we want time wise correlation, that when layer A was deposited at the same time what is the layer in the other succession, in that case it is called time parallel correlation, and biostratigraphy and chronostratigraphy becomes very important. Lithostratigraphic units to be defined based on actual lithological character, this I have been emphasizing. For example, it should not be solely based on geophysical parameters. I mean to say, this is possible for some kind of correlation which can have practical implication, but we cannot call that correlation as the lithostratigraphic correlation. When I say it is not possible, that means it is not possible within the lithostratigraphic realm. Unconsolidated sediments can define a lithostratigraphic unit. Therefore, the degree of lithification or whether at all lithification has happened, cementation, whether the rock is well cemented, coherent as a solid unit, does not matter in case of lithostratigraphy. Another point, the inferred geological history, which will come after linking stratigraphy, structural geology and tectonics, the depositional environment, the biological sequence, etc., are not useful in lithostratigraphy. It is important. So, this means what? Does it mean that geological history is not important, depositional environment is not important, biological sequence is not important? No, they are absolutely important, and they all have their implications even in industrial aspects of geoscience. But when we are talking about lithostratigraphy, they do not bring these things. We can say this is the lithostratigraphic information, and then we are adding up the geological history, the depositional environment and the biological sequence to bring a coherent picture how the terrain has evolved with time. So, as I have told earlier, fossils might be used in lithostratigraphy, particularly in the offshore area. This has been found useful, and in what way? Oyster rich sandstone, coquina, coral reef, graptolitic shell. So, here mere appearance is told that graptolite is present in the shell, coral reef, a reef made up of coral, sandstone where there is oyster, but we are not looking into what kind of oyster, what are the genera, species, what are the morphological details are not covered in defining lithostratigraphy. Two formation can be distinguished based on coarseness of the fossils, for example, foraminifera. Can we call aquifers, oil sands, coal beds, etc., the quarry layers as lithostratigraphic unit? The answer is yes, but we are considering them informally. Economically exploited units can be considered informally, and this point I have already referred in the beginning of lithostratigraphy. Soils and paleosols, can they be used? Note, soils are not considered as lithostratigraphic unit. Soils have been classified, but those are not considered in lithostratigraphy. Pedostratigraphy is important, but pedostratigraphy, if is done, should be recognized as pedostratigraphy, not as lithostratigraphy. Soils and paleosols are can be defined by layers composed of in situ products of weathering or of older rocks, which may be of diverse composition and age. The eroded material from several places can be deposited in one place. So, in that case we are getting diverse composition, and the rock particles coming from different sources. So, if you date those rocks, you may get the ages which are different. These are the ages of the provenance and not the depositional age. The depositional facies are the informal units. The graptolitic facies, the conglomeratic facies and the black shell facies are the examples of informal lithostratigraphic unit. Black shells classically have been said that they were deposited in a euxinic marine condition, in an anaerobic condition. However, in shallow seas, suppose the top water layer has become ice due to climatic change, and then there is restriction in the water circulation within the basin. Black shell can also develop in some of the areas having fjords. Where a binomial taxon has been used, the generic name is to be abandoned. For example, the scientific name of any organism is given in terms of genus followed by species. So, take an example of a bivalve, Myophorella clavellata. Now, if we are using it in the lithostratigraphic scheme, we have to drop the generic name or the genus name which is over here. So, if this name is out, what remains is the clavellata formation, and this is acceptable to use. In this case, in the species name, the first letter was in small, but when we are writing here, the first letter will be in capital. We are now going to see another informal term in lithostratigraphy called lithodemic unit, also in short called as lithodem. This is one of the basic units. What is it? It is a body predominantly of intrusive, highly deformed and or metamorphosed rock. So, it can be intrusive rock, it can be highly deformed rock, it can be a metamorphosed rock which is highly deformed. Now, the lithodemic units essentially are non-layered or non-stratiform units. So, we cannot see beds within it, we cannot see floor layers within it. So, they are non-foliated, we can call them non-schistose, we can call them non-gneiss, and of course, there is no bedding, no lamination, no stratification. The word lithos in Greek means stone and demos means body. So, it is like a stone body. In fact, also it is interesting to note that there is a journal, the name is Lithos. Now, several lithodems constitute a suit, a plutonic suit, a metamorphic suit. For example, several suits constitute a supersuit. So, that means lithodems, suit and supersuit progressively from lower rank to the higher rank for the non-layered rocks. The word lithodem is rarely used in stratigraphy. This has been observed by looking at the literature. And the research paper that says that the term lithodem is very rarely used in stratigraphy, that paper itself is also much less cited. Lithodems do not follow the law of superposition because there is intrusive or cross-cutting relationship. So, it is not that as we go upward we are going to get the younger rocks. It may not be valid all the time. The lithodems can be so complicated that finding out the sequence is very difficult. This is the statement given in the geoscience literature, but it does not mean that we will follow it. We understand that we are seeing a lithodem, it does not mean we will stop trying to find out the sequence, or some previous author has designated as rock unit as lithodem, it does not mean we will stop investigating. That is what I write. It does not mean that we will not try to find out the sequence. A suit can consist of two or more than two lithodems or one named and one unnamed units, that is possible. For example, if this is a suit, here we might be able to define a lithodem, but in portion B we are not defining any lithodem. Nature has too much of variation, so you see the lithostratigraphy, lot of subjectivity is there. If we are tracing laterally a suit, and it may be possible that it may lose its formal division. Suppose the S is a suit and which has a formal division into B and A. Once we are tracking laterally, we still find a suit, but we do not find the division between A and B over here, and it is okay in lithostratigraphy. Now, my comment is, it is possible in other stratigraphic correlations as well. Consider two ranks, capital A, which is higher rank than smaller rank, smaller a. In that case, it is possible that within A, A1, A2 and A3, and then we might be able to correlate with another succession A, but here AI are not defined, and this is possible. Definition of a lithodemic unit should be based on a full knowledge as possible of its lateral and vertical variations and its contact relations. That means, if we find a complicated cross-cut relationship that veins have intensely cut a rock body, we cannot just say that it is lithodemic unit and finish our work. We have to find out and understand the contact relationships very well and the lateral variation and vertical variation of the geometry that we are observing. For example, this is an exposure and I have studied over here and found a lithoderm. Then horizontally try to see whether it is continuing, and vertically up also try to see how things are changing. The type locality and the reference locality for the lithoderms should be designated. We have to announce in publication in which locality we have seen. Now, my point is that a field geologist's first location of study need not be the type locality. A field geologist should see as much as possible by taking several traverses and then decide which traverse is the best to define a lithostratigraphic unit such as formation or a lithoderm. Two rock units of same lithic character but of different ages may not be considered as a lithoderm. So, here you note that the term age has come from where we will get. Here we are talking in terms of absolute age and the geochronological method. Suppose the ages are available, and then we are finding in the two rock units that there are same lithic character, cross-cut relationship, complications, cross-cut relationships, but we know that they are of different ages. So, in that case it is recommended do not call them as a single lithoderm. Use of the word zone to represent lithoderm is informal. For example, if I say mineralized zone, contact zone, pegmatitic zone to represent a lithoderm, then we are talking it informally. Boundaries of a lithodermic unit are to be marked by lithic change. So, the lithodermic units and their boundaries, say this is a lithodermic unit we have observed, then its bottom boundary and the top boundary are to be well marked. That means, find them out and do geological studies, characterize it at the bottom and at the top. Now, the margin of lithodermic unit A can be either margin of another lithodermic unit B, or the contact can be depositional, intrusive, metamorphic or tectonic. I hope it is well understood. The depositional contact can be in terms of unconformity and tectonic contact can be a fault plane. Whether the term lithoderm can be used to describe layered intrusion is not very clear. We said that the intrusives, we can use the word lithoderm, but what if the intrusives are layered itself? We have said lithoderms are used for the non-layered rocks, but what about the layered intrusions? This is not very clear. Should individual dikes of a dike swarm be considered as a lithoderm? This is an open question. Or the entire dike swarm can be considered as a single lithoderm. That is interesting. Lithoderm is also sometimes spelled as lithodem, that means the E is sometimes dropped. Lithoderm seems to be a neglected term in geological publication, as I told you. Lithoderms are mappable and traceable in surface and subsurface. That means, In an underground mine also lithoderm can be defined. A single rock or more than one rock can define a lithoderm. Let us present an example of lithoderm from Indian stratigraphy. That is map of India. This place is known as the Shingbhum region. Here is a big city Kolkata, and here is the detail of the map. Paleoarchean rocks, Meso-Neoarchean rocks and Paleo-Meso-Proterozoic rocks are exposed in this place. We are going to see the Champua Soot TTG group of rocks, which is given by this red color. These are the exposures, and this has been described as a soot. A soot consists of several lithoderms. So, these are the places where the lithoderm has been found. That is the Champua area. The Thakurmunda area is here, and then other locations can be seen. Kalikapur is over here. So, west of Kalikapur is we can find lithoderm. Much west of Goru Mahishani, if we go, we can find out the lithoderm, and then the soot has been defined. Granodiorites is in the composite Shingbhum soot. So, here is a term Shingbhum soot, consists of several domal granitoid bodies and comprises of granodiorite. In the composite Shingbhum soot consists of biotite granodiorite, granite, monzogranite and tronzemite to tonalite, and ages of these bodies range between 3.25 to 3.38 billion year, and that is why it is placed over here in the succession.